93% of our cars run on oil. But oil is running out. In 50 years, the production of oil will be half of what it is today. Basically, we need an alternative. Biofuels are a good choice because we can continually make them using the sun's energy. Corn can produce 402 gallons of biofuel per acre, while microalgae can produce 5,020 gallons of biofuel per acre without taking away from our food sources and without increasing strain on our fresh water supplies. 846% of the U.S. cropland would be required for corn to meet half of our transportation fuel needs. Only 2.5% would be required for microalgae to meet the same need.
Currently, at this point in time, microalgae is one of the more expensive bases for biofuels. In order to overcome the high initial costs for farmers to switch over to microalgae, you could look at doing government subsidies, as well as we can look at government-run facilities, which would be able to run at face value and not worry about being profitable.
The main engineering challenge is improving the technology and getting the infrastructure there so that the capital cost is reduced. Another challenge is choosing the optimal strain of microalgae so that there's still a high yield and it uses salt water, and yet it's not toxic to the environment if it is spilled.
In the United States today, a vast majority of biofuels come from corn and soybeans. Research has shown that biofuels derived from algae can be a viable alternative to replace biofuels that use our food crops. In a study conducted by Massey University in New Zealand, 2 different types of growth techniques were investigated, and those were raceway ponds and photobioreactors. Raceway ponds use closed loops of water to grow algae on the surface, and they're actually very large in size. The largest is 440,000 square meters, so pretty big. Photobioreactors, however, use closed transparent tubes that gather sunlight and circulate a microalgal broth throughout them to stimulate the algal growth. Once the algae is harvested from either of these techniques, it's turned into a parent oil, which is then broken down into a useful alcohol by a complex chemical reaction known as transesterification.
There are benefits to genetically modifying the microalgae crop in order to increase the yield per acre while also reduce the toxicity of the crop.
So the triple bottom line considers people, planet, and profit. Now, these are also called the 3 pillars of sustainability. People benefit from microalgae because more job opportunities are created in America. The planet benefits because microalgae is a carbon-neutral source of biofuel. And the profit benefits are that the energy return on investment for microalgae versus ethanol from corn is also much higher. Remember, when compared to corn as a biofuel, microalgae production uses less fresh water and less cropland. With the correct funding and a bit of ingenuity, microalgae as a biofuel has the potential to revolutionize the production of energy.
You're live.
Oh, hello there.
Camera's off.
Oh, you know what?
The crop.
We can cut this out, so it's not a big deal. No, don't start it. Perfect. Boom.
The subsidized government.
That's fine.
What we need to implement.
Just power through it.
Doing